An earthquake of magnitude 7.1 is a city killer. When the seismic alarms blared across Southeast Asia, the sheer numbers suggested an absolute catastrophe was unfolding. 78 million people across 5 countries felt the ground heave beneath them. From the northern tip of the island of Sabah in Malaysia, radiating outward for thousands of kilometers to high-rise apartments in Singapore, the shockwave was undeniable. Authorities moved instantly. Disaster response teams mobilized, coastal patrols were deployed, and coastal residents braced for the ocean to recede. The expectation was devastation. Yet when the sun rose, the death toll was exactly 0. There were no injuries. Not a single building collapsed. The tsunami never materialized. To the general public, it looked like a miracle. But to seismologists, it was a terrifying geological anomaly that has forced us to confront a completely unmapped danger. The monster that shook Malaysia didn't come from a known shallow fault line. It came from the ghost of an ancient ocean, erupting from a depth that defies the very laws of physics as we understand them. And while this deep rupture spared millions of lives, it exposed a ticking time bomb right at the surface. One that Malaysia is woefully unprepared for. At 12:57 in the morning local time, the ground beneath northern Borneo lurched violently sideways. In Kota Kinabalu, the coastal capital of Sabah, residents in high-rises were thrown from their beds. Ceiling fans swung wildly out of control. Heavy wooden wardrobes burst open on their own, and the sheer structural groaning of concrete filled the air. Barefoot tourists in waterfront hotel districts were evacuated down emergency stairwells and huddled in open-air parking lots, clutching passports and phones, terrified of a looming tsunami. The energy radiating from this epicenter was so immense that it refused to stop at the Malaysian border. Felt reports poured into global seismic centers from Brunei, the Philippines, Thailand, and even Cambodia. In Singapore, a staggering 1,500 kilometers to the southwest, residents in eastern neighborhoods flooded social media, reporting loud bangs and apartment towers swaying in the night. When the United States Tsunami Warning Center finally issued their bulletin, the outcome was baffling. There was no tsunami threat. Not because the earthquake lacked the power to displace an ocean, but because its source was located impossibly deep within the earth. To understand why this magnitude 7.1 earthquake was so bizarre, we have to look down, far down. When the United States Geological Survey and global seismic networks triangulated the source of the rupture, they found the epicenter was located an astonishing 620 kilometers beneath Sabah. To put that into perspective, that is deeper than almost any earthquake ever recorded. It is a distance farther straight down into the earth than the drive from London to Paris. At this extreme depth, we are well into the Earth's mantle, an environment of unimaginable heat and crushing pressure. And this presents a massive scientific problem. Traditional earthquakes should be impossible here. Earthquakes, as we generally know them, happen when brittle tectonic plates grind together, build up friction, and violently snap. But at 620 kilometers below the surface, rock doesn't snap. It is so hot that the rock is actually ductile. It behaves more like incredibly thick, heated plastic. You cannot break it. So, what caused a magnitude 7.1 shockwave in a place where rocks can't crack? The answer lies in a phenomenon known as transformational faulting, and it is one of the most violent, instantaneous processes inside our planet. Seismologists, tracing the rupture, realized it originated on a hidden, subducted slab of rock that does not appear on standard tectonic models. This is likely the ghostly remains of the Proto-South China Sea, a theoretical ocean basin that was swallowed by the mantle roughly 16 million years ago. As this dead ocean floor continues its slow, agonizing descent into the fiery mantle, it brings with it deep earth minerals like olivine. Under the crushing pressure of the deep mantle, hundreds of thousands of times greater than the pressure at sea level, the molecular structure of that olivine can no longer hold its shape. In a fraction of a second, the crystal structure collapses and rearranges into a much denser configuration. This phase change happens in a localized flash, triggering a massive, cascading implosion that releases a colossal amount of kinetic energy. The rock didn't break, it transformed. Because this violent transformation happened 620 kilometers away from human civilization, the Earth's thick mantle and crust acted as a massive planetary shock absorber. Most of the devastating energy was absorbed and dissipated before it ever reached the surface. By the time that magnitude 7.1 shockwave reached the streets of Kota Kinabalu, it had been diluted to a heavy rolling sway rather than a sharp, destructive jolt. But this geological shield has created a dangerous, potentially lethal illusion of safety. The deep earthquake was completely harmless, but the surface region of Sabah is a tectonic powder keg. Borneo is often mistakenly viewed as a stable, safe haven, insulated from the violent ring of fire that plagues its neighbors in Indonesia and the Philippines. This is a deadly misconception. Sabah sits squarely at a chaotic, hyperactive tectonic collision point. Three massive pieces of the Earth's puzzle, the Sunda Plate, the Philippine Sea Plate, and the Indo-Australian Plate, all violently converge right beneath northern Borneo. The region is laced with shallow, highly active fault networks, including the Crocker Fault running directly beneath Kota Kinabalu and the Mensaban Fault nearby. The pressure along these shallow lines is constantly building. The real danger to Malaysia is not 600 kilometers down in the dark of the mantle. It is directly beneath their streets, their schools, and their high-rises. Sabah has experienced a massive population and construction boom since the 1980s. The landscape has been transformed by modern development, but there is a glaring, terrifying gap in this infrastructure. Malaysia did not introduce a national seismic building code until late 2017. That means nearly every single building, bridge, and piece of critical infrastructure constructed before 2017 was designed only to carry gravity and wind loads. They were engineered to stand up straight and resist being blown over. They were never engineered to absorb the aggressive, horizontal, side-to-side shearing forces of a shallow earthquake. A recent sobering government-initiated vulnerability study assessed more than 500 buildings across 7 districts of Sabah. The findings were horrifying. In key districts alone, over 160 major buildings were classified with grade 4 vulnerability. This means they are at severe risk of partial or total collapse if a moderate, shallow earthquake were to strike. These aren't hypothetical structures. These are residential blocks, commercial centers, and public facilities that currently house tens of thousands of people daily. The infrastructure is essentially a concrete house of cards waiting for the table to be bumped. And we don't have to guess what happens when the table gets bumped. We just have to look back to a tragic morning on June 5th, 2015. A magnitude 6.0 earthquake struck the same region, near the iconic Mount Kinabalu. On paper, a 6.0 is mathematically over 20 times weaker in total energy release than the 7.1 that recently shook the deep mantle. But the 2015 earthquake had a deadly, defining difference. It was shallow. It erupted just 18 kilometers below the surface. Because it was so shallow, there were no hundreds of kilometers of thick rock to absorb the shockwave. The violent, unfiltered shaking tore massive granite boulders, some the size of cars, loose from the sheer face of Mount Kinabalu. Those boulders crashed down onto crowded climbing trails at terminal velocity. 29 students and 8 teachers from a primary school in Singapore were on the Via Ferrata climbing route when the mountain shook. 18 people were killed that day, including 6 young school children. That magnitude 6.0 disaster is the true devastating face of Sabah's seismic threat. The sheer destructive power of a shallow rupture in this region is immediate and lethal. The magnitude 7.1 anomaly that just occurred was a massive warning shot fired from the deep earth. It proved beyond a shadow of a doubt that immense amounts of tectonic energy are moving and shifting beneath Southeast Asia. It proved that unmapped geological ghosts are still hyperactive millions of years after they sank. But most importantly, it served as a stark reminder of what is waiting right at the surface. The deep faults have spoken, but the shallow faults are holding their breath. The tectonic stress is still building at the collision point of those 3 grinding plates. A shallow, moderate to severe earthquake hitting Kota Kinabalu is not a matter of if, but when. And with 160 major buildings structurally unfit for the shaking to come, and a seismic building code that is barely a few years old, the gap between preparation and absolute disaster is razor thin. The deep earth gave Malaysia a second chance. Whether the region can reinforce its cities before the shallow earth wakes up remains remains the most critical question of the decade. If you want to keep diving deep into the geological mysteries, the unmapped anomalies, and the earth-shattering forces that are actively shaping our world right beneath our feet, hit that subscribe button and turn on notifications. Leave a comment below on what tectonic mystery we should investigate next, and I'll see you in the next video.